Hi students, coming to the next topic in the subject operating system is processor scheduling. So you call it also CPU scheduling. A processor is nothing but central processing unit, CPU. Now let us see how the CPU is going to be scheduled, whatever the process that the user is requesting. So how those processes are going to be scheduled to execute the operations. Now let us see. So actually the process scheduling is a change of ready to running state of a process. Whenever the process is changing its states from ready to running, okay, so in that case the process is going to be scheduled, means it is going to be allowed some time to each process. So that you call it as a process scheduling. A CPU scheduler selects process among the processor. Suppose here so many processors are there, P1, P2, P3, so many processors are there. So among all these processor, the CPU is going to be scheduled. CPU scheduler selects the processor. Select the processor among these all processor that are ready to execute. So it takes, it means the CPU. Let me write that. CPU takes the process among all these processes that are ready to execute, and allocates CPU to one of them, and allocates CPU to one of that process. Okay, so here P1, P2, P3, so many processes are there that are requested by the user. So if this processor has to be executed by the CPU, then the CPU has to go schedule that which process it has to be take. Okay, so the processor is decide and selects a process which is ready to execute, and that process will allocate to CPU to perform the operation. So that you call it as a processor scheduling. In this processor scheduling, you can see one term like short-term scheduler. You also call as a short-term scheduler. Also called as dispatcher. We call it as a dispatcher. So what is the operation of this dispatcher in CPU? So here the dispatcher executes most frequently and makes fine-grained decisions of which process to execute next. Means this dispatcher is going to be decide. It selects the process which is most frequently and executes. Let me write that. Execute most frequently process and make grand decision of which process to execute next. That will indicated by the dispatcher. So the dispatcher, we call it as a short-term scheduler. So to allocate a processor to the CPU, the dispatcher is going to be send that process which has to be executed next. So that information will be stored in the dispatcher. That is a short-term scheduler. Now let us see the CPU scheduling decisions. So how the CPU is going to be schedule the process. CPU scheduling decisions may take place when a process, so let me explain those points. So when the CPU decisions or may take place when a process, first one, switches from running to waiting state. So in this case, the CPU takes one decision and it schedules that process when it switches from running to waiting state. And the CPU scheduling decisions may take place when a process switches from running to ready state. So for that type of process also the CPU schedules one time. And the CPU scheduling decisions may take place when a process switches from waiting to ready state. And the last, the CPU scheduling decisions may take place when a process terminates. So these are the decisions at this time when the process switching from ready to waiting and ready to running to ready, waiting to ready, and it terminates. The CPU is going to be scheduled some decisions. So here in this selections, the process, this 1 and 4 you call it as, the 1 and 4 you call it as a non-primitives, non-primitive scheduling. And the remaining one are the 2 and 3. The 2 and 3 you call it as a primitive schedulings. Primitive scheduling means here if you observe 1 and 4 saying that when the process switches from running to waiting, so here the process is shifting from running to waiting, okay, and the next one is the process is going to be terminate. So these two terms we call it as a non-primitive. So what do you mean by this non-primitive? Non-primitive scheduling means no choice will be there to the processor, okay, no choice in terms of scheduling. CPU has to need process until it goes for writing or terminates. Means here there is no choice for CPU scheduling. So in the non-primitive means there is no choice for CPU scheduling because it has to take the next new instruction, because it keep process until it goes for waiting or terminate. The CPU has to keep process until it terminates or waiting for the process to come. So here there is no decision. It has to be take the next coming whenever it is going from running to waiting state. So there is no option for the CPU to take it has to wait or something. It has to complete that process, and whenever it terminates, the CPU has to take the next process in the queue only. There is no option. So whenever it is terminate, whenever the CPU terminates or enter into waiting state, it has to take the new process which is present in queue. So there is no choice for the CPU. So this term you call it as a non-primitive. So this I will explain clearly in the coming video, but I just given the small brief description about non-primitive. And coming to the primitive scheduling. So here the primitive scheduling running to ready and waiting to ready. So I call these two process, you call it as a primitive scheduling. Why I call these two as a primitive scheduling? Because this primitive is nothing but it is based on priority. CPU executes based on priority. That you call it as a primitive. What do you mean by this? It's based on priority. Means here the process switches from running to ready state and waiting to ready state. Whenever the CPU is in ready state, the CPU has choice. It can execute that process, or if some another input output interrupt is occurred or some other device, the highest priority process comes into the queue, it will execute that instruction and keep holds this process. After the completion of that process, the CPU again come back to this ready state process. Okay, so here a choice will be there for the CPU. A choice will be there. So it is execute based on the priority. Even though it is executing one instruction, it is going to be it is in ready state. It will stop that process and takes the priority request and execute that priority instruction or the process. So that you call it as a preemptive. Preemptive means the processor has a choice, it can take the priority process. And non-preemptive means the process doesn't have any choice. First it has to complete that work until it terminates or until that process went to the waiting state. Okay, so whenever the process is terminate and whenever the process is in waiting state, then only the CPU can take the next process. Okay, so until that process relieves from CPU, the CPU has no choice to take the interrupted request. That is about the non-preemptive. So these are the CPU scheduling decisions takes place when a process is changing its states. Thank you.